Hi class, in this section what we're going to do is we're going to talk about trigonometric integrals. In the next section we'll also be talking about trigonometric substitutions for integrals, but this is just kind of just basic integrals involving different trigonometric functions. And how you solve each of these are generally going to come down to some type of substituting in or rewriting the integral into a simpler form. So to be able to do that, the first thing I want to go over real quickly is the trigonometric identities, right? So the first ones here I have are the reciprocal identities. So like sine is the same as 1 over cosecant, cosecant is the same as 1 over sine, secant is the same as 1 over cosine, cosine is the same as 1 over secant, tangent is the same thing as 1 over cotangent, cotangent is the same thing 1 over tangent of x. And then also here we remember that tangent of x is the same thing as sine over cosine, and cosine or cotangent of x is the same thing as cosine over sine. So those are your basic reciprocal identities. But then we also have the Pythagorean identities here. So like sine squared x plus cosine squared x obviously is equal to 1. 1 plus tangent squared of x is equal to secant squared of x. And 1 plus cotangent squared of x is equal to cosecant squared of x. Finally, we have some of these different identities, the double angle ones. So sine of 2x is equal to 2 cosine of x sine of x. Now the cosine of 2x, the double angle of cosine of 2x, can be written a bunch of different ways. So it can equal cosine squared of x minus sine squared of x, or cosine of 2x can equal 2 cosine squared of x minus 1, or cosine of 2x can equal 1 minus 2 sine squared of x. The double angle formula for tangent of 2x is equal to 2 tan x divided by 1 minus tan squared x. The reason these are important is notice how we have a sine of 2x, a cosine of 2x, tangent of 2x. Well, whenever you use the double angle formula, it just gets the x by itself on the inside. There's no 2x anymore. And we need that often when we integrate. Also, these are the power reducing formulas. These are going to come in handy a lot in the lecture, in the examples I have. So sine squared of u is equal to 1 minus 2u divided, or cosine of 2u divided by 2. Cosine squared of u is equal to 1 plus cosine of 2u divided by 2. And tangent squared of u is equal to 1 minus cosine of 2u divided by 1 plus cosine of 2u. All these formulas here, right, the power reducing, the double angle, the Pythagorean identities, and the reciprocal identities, right, these are all going to be incredibly important when we go to solve our trigonometric integrals. All right. So for trigonometric integrals, if needed, what you're going to have to do, your goal is you're going to rewrite the integral into a form that can be integrated. Right? So generally you'll start with something that can't be integrated as written, and you're going to use your trigonometric identities to get it to a form that can be integrated. All right, so let's start with a simple example. So I want to evaluate sine cubed of x dx. And so right there, there's a problem. There's no formula I have talked about in class so far that involves integrating sine cubed of x. Now I know how to integrate sine of x, okay, so that's something, but not sine cubed. So the first thing you're going to do here is you're going to rewrite it by peeling off, I say peeling off, but you're going to peel off the sine squared. So sine squared of x times sine of x is still equal to sine cubed of x. So I'm just rewriting it. Now what makes this integral hard right now is the sine squared. So I'm going to need some type of trigonometric identity to substitute in there. So I'm going to rewrite this using our Pythagorean identity. Right? So I'm going to, where I see the sine squared of x, I'm going to write 1 minus cosine squared of x. Now don't forget you still have the sine of x out here. So I'm going to distribute like this. Now what I notice here is I know how to do this integral by itself. I know how to do this by itself. So I'm going to break it up into two different integrals. Now sine of x is very easy to integrate. Here, how would you integrate cosine squared of x times sine squared of x? Well, it's a U-substitution problem. I would just let u be sine of x and go from there. So I won't waste time in this lecture to do that. But if you did, obviously sine of x integrates as minus cosine of x. And this right here, using your U substitution, letting u be sine of x, you would get cosine cubed of x times 1/3. So the trick here to doing this problem was knowing to rewrite, or first rewriting sine cubed of x as sine squared of x times sine of x. All right, let's do another one. Let's look at this one. So it's the integral of sine to the 4th power of x cosine to the 5th power of x dx. How would we even do this one? All right, so again, you can't just like U-substitute something here. Like if it was just sine of x times cosine to the 5th of x, you could, but you can't as written. So you're going to need to rewrite this. All right, so the first thing I am going to do, I'm going to leave the sine to the 4th power of x alone. I'm going to peel off 1 cosine of x. All right, that's going to leave cosine to the 4th, but I'm going to write that as cosine squared of x squared. Okay, now the reason I want to do that here is if I can somehow rewrite cosine squared of x in terms of sine, I can do a U substitution, like just let u be cosine of x. Well, I can replace this cosine squared of x using the Pythagorean identities as 1 minus sine squared of x, and then don't forget you have the square. All right, unfortunately what you're going to have to do is some algebra here. You're going to have to square this. So when you do square that, you still have sine to the 4th x. 1 minus sine squared of x squared squares to be this. Next, what you'll do is you will distribute everything. So you're going to distribute the sine 4th to the x and the cosine of x to everything. Now what you're going to do is you're going to break this up into 3 different integrals. And then when you do, right, here it's just going to be the U substitution again. I'm going to let u be cosine of x. Du then is sine of x. And it's the same thing over here. Excuse me, I'm going to let u be sine of x. I'm sorry, forgive me on that one. Sine of x. And then my du here will get replaced by this by minus cosine of x dx. When I do that, all right, you'll see that it's just simply going to integrate into all the following right here. So again, you're going to let u be sine of x, and that means du is going to be cosine of x dx. I think I misspoke and said minus cosine before. Sorry about that. Over here, you're going to let u be sine of x, and that means du is going to be cosine of x. And again, here you're going to let u be sine of x, and du be cosine of x dx. And when you do, it simply integrates to all of this. All right, let's do another one. So this is sine to the 4th power of x dx. Now notice if I go back here, give me to go all the way back here. This was sine cubed here, and then the goal, once you got it down to here, you let u be cosine of x, and that was easy. But that's the method you handle it when you have an odd power here. Now let me go back. Here I have sine to the 4th power of x dx, so it's not that easy. So the first thing I'm going to do is I'm going to write it as sine squared of x squared. Now the squared in here is the issue, so I have to do something to get rid of it. So what I'm actually going to do is I'm going to power reduce it. Right? So sine squared of x power reduces to 1 minus cosine of 2x over 2 squared. All right, now here's the hard part. I need to square all of this. When I do, this is what I get. All right, now it's not too hard as written. All right, the problem is like I can integrate 1, I can integrate minus 2 cosine of 2x. It's this cosine squared of 2x that's the issue. All right, so I'm going to rewrite it as 3 separate integrals. All right, this one's a piece of cake, this one's a piece of cake. I'm just taking the 4 out. This one's not a piece of cake. All right, so what I need to do is, man, it's like the squared makes it a problem. Well, how do you reduce or get rid of the square? You just power reduce this again. So this integrates as x. This right here, minus 2 cosine of 2x dx, will just integrate as sine of 2x. What would happen? You'd have to do a u sub, and you'd get a 2 in the denominator, but this 2 would cancel with it. When I power reduce this, it just becomes 1 plus cosine of 4x over 2. The reason it's 4x is in here is it's 2 times u. Well, my u is what's inside here, so it's 2 times 2x gives me 4x. So I just have to integrate this. So this splits up into 2 different integrals. integral of 1/2 dx and 1/2 cosine of 4x dx. Well, now I can integrate it as written. So 1/2 integrates as 1/2 dx. Cosine of 4x integrates as 1/8 sine of 4x. And you're done. Just like that. Combine like terms next. If you wanted to, you can x, 1/2 x, and then don't forget your constant of integration. All right, let's do one more in this video, and then I'll split this video up into a second part for you to follow right after this. But now I have the integral of sine squared of x cosine to the 4th power x dx. All right, so notice how I have like this cosine to the 4th power here and the sine squared here. So what you're going to want to do is you're going to want to get it all in terms of cosine to start with. All right. So like if this again, if the sine was by itself, and it wasn't squared, you could just let u be cosine and go from there. So the first thing I'm going to do this way is I'm going to power reduce the sine squared of x. So power reduction of sine squared of x becomes 1 minus cosine of 2x over 2. And as we've been doing, I'm going to rewrite cosine to the 4th power of x as cosine squared of x squared. Now what I'm going to do next here is I'm going to power reduce this one, right? Because the squared is what's making it hard. So when I power reduce cosine squared of x, I get 1 plus cosine of 2x over 2. The hard part here now is I'm going to have to square all of this right here. So when I square this, it becomes this right here. Oh, now this is where the algebra gets even crazier, right? I'm going to have to multiply this by this right here, right? So when I do that, this is what happens. This is all the craziness that I get right here. All right, so now let's clean this up a little bit. I'm going to take the 1/8 out. I'm going to combine all the like terms that are listed in there. And notice here what I get is I get 1/8 comes out. Cleaning up all this mess, I get 1 plus cosine of 2x. These two things I can just integrate by themselves, so I don't have to worry about that. But now I have this minus cosine squared of 2x and minus cosine cubed of 2x. So I'm going to have to figure out a way to integrate both of these. All right, the first thing I'm going to do here, the squared makes it hard, so I'm just going to power reduce it. When I power reduce cosine squared of 2x, I get 1 plus cosine of 4x over 2. Here, what I'm going to do is I'm going to peel a cosine of 2x off. So I'm going to be left with cosine squared of 2x. So I'm going to have to substitute something in for this. And I'm just going to use the Pythagorean identity. And for cosine squared of 2x, I'm just going to put in 1 minus sine squared of 2x. All right, here, I'm just breaking this up as 1/2, and don't forget the minus out there, the minus 1/2 cosine of 4x. Next, I'm going to combine the like terms, and I'm going to distribute over here. So when I combine the like terms, 1 minus 1/2 is this, plus cosine of 2x minus 1/2 cosine of 4x. Now I'm distributing this cosine of 2x here. So I have minus cosine of 2x, which is great because it'll cancel with this. And then I have sine squared of 2x, cosine of 2x. All right, so the cosine of 2x cancels. All right, so I'm just left with this 1/2 minus 1/2 cosine of 4x plus sine squared of 2x, cosine of 2x. So this is great. Like this can integrate by itself. This can integrate by itself. Over here, I'm just going to have to do a U-substitution. I'm just going to let u be sine of 2x. And when I do, 1/2 integrates as 1/2 x. Minus 1/2 cosine of 4x integrates as minus 1/8 sine of 4x. And this, letting u be sine of 2x, will integrate to 1/6 sine cubed of 2x. All right, I'm going to continue this PowerPoint slide, this PowerPoint lecture in a second video, but we'll stop it here and pick it up in the next video.